Support for today's Heat Treat Radio episode is provided by the Heat Treat Buyer's Guide. Use the free online directory to find heat treat service and product providers near you. Go to www.heattreatbuyersguide.com. And thanks for joining us for another episode of Heat Treat Radio. Today, our host and Heat Treat Today publisher, Doug Glenn, is interviewing Mark Mills, a leading energy and technology expert in the nation and senior fellow at the Manhattan Institute. Mark shares his keen understanding of how energy demands and crises affect the economy and how it relates to the material sciences, like heat treatment. If this interview piques your interest, check out his recently published book called The Cloud Revolution: How the Convergence of New Technologies Will Unleash the Next Economic Boom and Roaring 2020s.
Well, welcome to this next episode of Heat Treat Radio. This is I'm really tickled about this interview. Get to interview, for most of you, this gentleman is a heat treat industry outsider. He's an outsider, but listen, he probably knows more about energy and emerging technologies than pretty much anybody in the industry. So I'm really looking forward to talking to Mark Mills today. Mark and I first met at the International Therm Process Summit in Dusseldorf in 2017, back in the heyday of Marcellus and Utica shale. So that was fun. So Mark, first off, welcome. Glad to have you here.
Thanks for having me. That was back when the dinosaurs roamed the earth, I guess, right?
That's right.
Long time ago. Seems like a long time ago.
It does seem like a long time ago. So let me give our listeners and viewers a quick idea of your background, okay, and then we'll jump into some questions. So I told Mark before we hit the record button, I said it's probably going to take me longer to introduce you than it is for the rest of the conversation.
They can always Google me in the magic machine, and they'll know more than they want to know anyway. But go ahead.
That's exactly right. All right. So Mark is a senior fellow at the Manhattan Institute, which is a conservative think tank in New York City. Also a faculty fellow at Northwest University's McCormick School of Engineering and Applied Sciences. A strategic partner at the Montrose Lane Venture Fund, I think you said it was, Mark, and Energy Tech Venture Fund. Okay. And before this, he was chairman and CTO of the ICX Technologies, which he helped take public in 2007, and is either author or co-author of 4 books. Right. And you can correct me on any of this. 2005 book, which I found to be an interesting title, The Bottomless Well: The Twilight of Fuel, The Virtue of Waste, and Why We'll Never Run Out of Energy. I thought that was great. And that was co-authored with Peter Huber, I believe. And in 2018, Work in the Age of Robots, which is interesting. Our publication just recently did some work with talking about how to work with robots. And then 2020, Digital Cathedrals. And then your most recent book, which I will ask you about. Last question I want to ask you today is about your book is just coming out, or has just come out, is The Cloud Revolution: How the Convergence of New Technologies Will Unleash the New Economic Boom and the Roaring 20s. Okay, so that should be interesting. So Mark's also been published a lot of articles: Wall Street Journal, New York Magazine, Forbes, USA Today, Real Clear, been on TV, which is CNN, Fox, NBC, PBS, and now Heat Treat Radio, straight to the top.
Top to the top, baby.
That's right. Also 2005, Comedy Central's The Daily Show with Jon Stewart, which, by the way, I watched. I like that one. He's also just recently joined the podcast ranks. So congratulations on that, with a podcast I will recommend, because I've listened to every episode so far, believe it or not.
Well,
all 3 of them.
That's right. Well, number 4 goes live in a few days. So
there you go.
And
so for those of you listening, the podcast is called The Last Optimist. And started on February 24th with Unleashing Innovation. So highly recommend that. Only other thing I want to mention about your background, Mark, was that you were in the White House's science office, staff consultant under President Ronald Reagan. So again, welcome. And my first question to you is this: did you ever meet Ronald Reagan?
No, I was a kid. And I like to remind people that I was still in diapers at that time, so it doesn't date me too much. When you talk to students, they hear Reagan, they think that it would be as if when I was a student, somebody came and talked to me and said they worked for Grover Cleveland.
Yeah,
it would have been unimpressive. I never met them. They kept those young. I was 20 something, and the kids worked in little cubicles and little cages, and you got fed your work. You worked 7 days a week. You did what you had to do. The president didn't meet with the kids.
Right.
That was, I know Peggy Noonan, who famously parlayed her speechwriter. She was a contemporary. I didn't know her then. I don't know her now, but she wrote some years later. She never met the president either.
Okay.
I had a hand in writing one of his speeches because the only energy speech he ever gave, I had a hand in. I didn't write the speech, but the speech writers were required to fly it by us techies in the science office to make sure they didn't screw up. So I rewrote some of that speech. It was fun.
Well, I was going to say that would have been right in the middle of the whole. It seems to me there was a lot of energy crisis things going on. He was coming off of Carter, so price fixing and
exactly. We had the combination of things. The '79 Iranian Revolution, which of course damaged Carter's presidency, also led to a 200% increase in oil prices almost overnight. And so the world was in thrall of the alternatives to energy and oil back then. And Congress in 1980 passed something I've been warning oil companies about ever since, the Windfall Profits Tax Act, to punish oil companies for making money for the foresight of having drilled oil before a price rise and storing it and selling it after a price rise, which used to be in business called a smart commodity play, but Congress criminalized it. It took, I think, 8 years before that law was repealed. It was a feckless law. It did not achieve its purposes. It just damaged American businesses. But anyway, I digress.
But you know what? It just goes to show you no good deed will be unpunished. So there you go.
Exactly. No, I think Congress may do it again. They're talking about it again.
Yeah.
But my book comes out at a curious time. I wrote it during COVID times, lockdown time, which is a dispiriting time to write an optimistic book. But I make analogies in my introduction to the book to the 1920s, which was also a dispiriting time. 1920 was the third wave of the 1918 flu, which in per capita terms was 400% more lethal than coronavirus has been. And it primarily killed young people. The coronavirus has primarily killed old people. So it was a devastating time. We came off a horrific world war. We were in the middle of massive race riots in the early 1920s of a level that are, well, frankly, unprecedented and still haven't been repeated, thank God. We had political turmoil over the fears of the Red Scare. This was right on the heels of the Bolshevik Revolution and the worries about communism infiltrating the Western world, and especially the United States. Sure. And so the world, though, technologically took off. I mean, it was 1920s were a time of great convergence of technologies of that era, not one thing. It was multiple things. We had the dawn of a practical automobile, the dawn of practical airplanes, the advent of radio communications, the proliferation of telephony in homes. We had pharmaceuticals appear for the first time in history, and chemical polymers that allowed cheaper products for consumers. It was a time of torrid growth that led to roughly 75 years of the greatest expansion of wealth and well-being the world has ever seen. It also didn't mean we didn't have wars. So as I pointed out in the introduction to my book, governments can do stupid things, and one would expect another war. And I wrote this right before the war broke out in Ukraine, not because I wanted a war, because we fight wars, unfortunately. And we can expect other recessions and depressions. That'll happen too. All of that happened in the 20th century, yet the technological changes of the 20th century, everybody knows, brought astounding advancements in well-being and wealth. So the question you would have is, could it happen again? Now, there are some economists, and it's typically the economists who say no. The new normal is slow growth. All the big things have been invented. I call them the new normalists. The new normalists are wrong. In my book, I set out to prove that we're on the cusp of a revolution, not in one thing, but in across all the same three fronts of transportation, machines, and materials and communications. Although the lead title is The Cloud, because at the center of it is something that really is unique. The cloud infrastructure is truly a unique thing in human history.
Yeah. Well, it sounds like a fascinating book. I may ask you a little bit more about it towards the end. So, but it sounds very good. No,
well, I think you might even enjoy it if you read it. It's available now at Amazon.com.
I got to get it. I do. Honestly, okay. I have not read it yet, but
there'll be a quiz too, but go ahead.
Yeah. All right. That sounds good.
And I do have several chapters on energy in the book, of course, because energy is impossible.
It's impossible. You mentioned materials though, Mark. Do you have anything on materials in there?
Yes, absolutely.
Okay, great. That's I can tell you a lot of people in our audience will be interested in that. So let me ask you the first question. I want to harken back to something you said, which I think will be kind of provocative for our audience, and that was when you were on the deadly serious Jon Stewart show. You said you said, or he said, I can't remember which one, said we don't have an energy problem, we have a technology problem. Yeah. Why don't you explain that, please?
Yes, it was an interesting show, by the way. I hope he picks up doing book interviews again on his podcast. It was the most interesting, and I can tell you this, and this is not to suck up to Jon Stewart, because you're not Jon Stewart and he's not doing TV anymore. But
that's right.
When you're on the book circuit, you don't expect people to have read your book. You really don't.
Yeah.
It's not a reasonable expectation, but you're happy to talk about your book because the whole point of writing it is you want people to know it exists.
Yeah.
He was the only person who had obviously read the book before I came on the interview. You could tell by the questions. He, very bright guy, very curious mind, and he was fascinated by this. And he got the point. And the point, of course, was, energy is physics. I'm a physicist, so I confess to that sort of bias. There's no limit to energy in the universe. There's essentially an infinite supply of energy. Energy is all around us in all kinds of forms. It's always a question of what technologies are available to tap into nature's energy forms, whatever the form is, in ways that are acceptable. And acceptable means affordable, reliable, clean enough, all the metrics that we care about in society. But it's always a technology problem. So if you think there's a shortage of energy, you're essentially saying we've stopped technology innovation. Now, you can have interregnums where the innovation slows down. It can be hard to find the new solutions and take time. So that would be the quote shortage, right? Shortages occur in the sense that we max out our access to land, because energy is always about accessing land somewhere. You always have to get ahead. You have to get your hands on land whether you're getting land where the wind is or land where the oil is. It's the same thing.
Or land where the sun shines or whatever.
Doesn't matter. So you have to pay for, whether politically or in dollar terms, access to land. And then you have to build machines. And building machines always requires the extraction of materials from the earth. And given your audience, always everywhere requires the application of heat to convert materials from one form to another. And the application of heat in physics, and your audience knows this, thermodynamically means you always have waste. That's why our other book the title was The Virtue of Waste. By that we meant was the virtue of waste is the fact of applying heat to bring order to the universe, get higher ordered materials. Means that's a virtue. We want to get higher ordered materials with lower entropy, higher quality steels, different kinds of polymers, these things that require heat. So the presence of waste is actually a direct indication, presence of waste heat, that we're doing a virtuous thing of creating order in our universe. Anyway, that's why we.
Not to say that we try to maximize the amount of waste, but the fact that we're creating waste shows we're doing something, and it's something productive.
No engineer ever maximizes waste. What engineers are stuck with is the fact of conversion efficiencies require you to. It's a misnomer. The idea that there's waste energy is a total misnomer. It is the price you pay to add to take entropy out of systems. It's the price you pay for conversions. It's a cost. Now you want to minimize the cost. So in engineering terms, it means minimize the amount of waste heat, because you spend all kinds of money making heat. So I don't want to throw it away needlessly.
Sure.
But every engineer knows this fact. If it costs me more to reduce the amount of waste heat than the money I have to spend to get additional input fuel, I'm going to buy the input fuel, because it's always about money. It really is for every business.
Yeah, right. So speaking of business, so our industry, which you know relatively well, having spoke over at the International Therm Process Summit, you got a good taste of it there. We are heavily natural gas, right? Especially North America. Now over in Europe where we met, wasn't so much that. I mean, they're still natural gas, but they have heavier emphasis on electricity as well. So it's heavy natural gas. Before the Ukrainian crisis, what was the long-term look for energy here, especially natural gas here in North America? And then I want to ask you after that, just a follow up. Okay, how has that changed since the Ukrainian crisis?
Yeah. Well, the long-term look was the same before as it is after in terms of the physics reality. That is, the world needs a lot more energy and would need a lot more natural gas. And the U.S. would be eventually, depending on what administration, what policies are in place from Congress, would eventually expand its production and its exports. That, in my view, is locked into reality. The velocity with which that happened is what Ukraine changed. And now we haven't seen evidence of the velocity changing yet, but I do think that the Ukrainian crisis will serve as a reset back to reality of what governments need to do both in Europe and here in the United States,
right,
to provide the kind of energy needed to make electricity and the kind of energy needed to make heat in process industries.
Yeah. So same, you say same, basically, not from a business side, you're saying essentially, well, let me ask you this. Let me ask you the next question, because this might really get to the gist of it. Because as you know, it's all about price, right? It's all about the price of it. So midterm or short-term, midterm natural gas prices here in North America.
Yeah.
What are you thinking? And what should heat treat natural gas users be watching to help them know what's coming down the pike?
Yeah, I think any big industrial users of natural gas have learned something in the recent decade of the shale revolution. The incredible increase in gas exports. U.S. is now the largest natural gas exporter in the world. Although Qatar is going to work hard to surpass this. They just announced tens of billions of dollars of investment in new LNG export capacity. And I suspect Australia is going to do the same. We don't have a similar response yet. So short term, we know that natural gas prices have migrated towards being commoditized like oil prices. So they have been dragged into the exchange markets of the world. And what that means in the short term is exactly what you're already seeing. Gas prices get dragged up as traders worry and think about where future supplies are going to come from. Right. So I think we're going to see more volatility in the future. But I made that prediction in 2015 in Dusseldorf. The volatility comes from the combination of expansion of the U.S. production and the commoditization of the market globally. So that's normal, which would argue if you're a big consumer to look to making favorable long-term contracts with suppliers. That pretty normal, whatever the commodity. But I do think in the short term, the markets will be stressed because there's going to be a lot of pressure to Europe's going to, I think, inevitably want to have more U.S. LNG. This will redirect LNG exports from Asia to Europe. That will, in the short term, push prices up because you can't build pipes fast enough. And believe me, Putin's going to build more pipes to China. That's one outcome you can almost take to the bank. Right? Yeah. But that takes time. So during the build out of those pipes and the competition for gas, and we'll see how this administration responds to expediting new export terminals. By the way, expediting export terminals to move more gas in the markets, I think counterintuitively will help lower gas prices. The more relief we put into the market of supply certainty, the more forward prices will, I think, get pulled down. Short term, though, of say, I think volatility with trending up, not crazy up, I don't think.
Okay.
If Europe tried to ban the use of Russian gas prices will go crazy up as they did in the short term, in the wind lull in Europe. Longer term, I'm very bullish. I mean, on gas prices being moderate and cheap again, because I mean, the U.S. is it can produce astonishing quantities of gas. I've talked to producers, and I won't name names, that when gas prices for consumers, you were all real happy when it was $2. But if you're a producer, you're not a happy camper. But producers were still making a profit at $2. Who
Yeah.
knew? I mean, it's
Yeah.
crazy. Nobody thought that was ever possible. So, and look, to be fair, if you're a consumer, you want $2, not $3. But given a world that used to see $5 and $10 gas, you know that you can live with $3 or $4 gas and do very well in the world markets because everybody else in the world is paying 5 to 15.
Yes,
So
exactly. Yeah.
And at those prices, let's just throw numbers 3 to 5 for the clearing price in the United States. The United States can produce just gas till it's coming out of our ears, and to use the honest expression, and ship it to the world, net landing in Europe for 6, 7, 8. This is, I just think it's the biggest single revolution that's still underappreciated is not the oil from this American production, but the gas.
The gas. Yeah. Yeah, exactly.
It's huge. It's monstrous.
When we return, Doug and Mark will discuss how heat treaters might feel the effects of the war in the Ukraine and the demands on energy. But first, are you wanting to purchase a new furnace or maybe some burners, baskets, and bearings? Or maybe just a consultation to keep you in line with the AMS 2750F standards? You can find North American heat treat providers of services, equipment, and related products on heattreatbuyersguide.com. It's a super simple search tool which allows you to browse by category or by searching the name of a product or company. This tool will help you streamline your purchases and expenses as you begin summer orders and want to maintain excellent results from your heat treat shop. Go to www.heattreatbuyersguide.com to start searching today. Again, that's www.heattreatbuyersguide.com. Now, back to the episode.
So let me ask you this. I'm curious about about Russia. And I don't know how much what goes on over there is going to affect us. Okay. But I guess I've got a couple questions about Russia. After the Ukrainian crisis is over, which let's hope it gets over soon, do you see Russia returning to be a major player, which I assume they are now, right? A major player in the energy market as far as actual ability to produce the energy? And do you think there's going to be any long-term pushback against buying energy from them because of instabilities or people not trusting or anything of that sort?
Back in the dawn of time, I was what you would call a cold warrior. I was in the weapons research and development business during the 80s. I've thought a lot about competition with Russia and the Soviet Union for a long time. Yeah, I'm no more expert than a lot of people, and I would commend Niall Ferguson's most recent writings on this. He's very astute about the history, as you know, of Russia. But I think it's pretty clear that a couple things will happen and a couple things could happen. The two things that will happen is that Russia will continue to produce gas. They don't have anything else to make money with. The other thing that will happen is that if the West doesn't buy it, other people will. Yeah. So India, Russia, China, African nations, South American nations. So there's lots of offtake, and the growth is in Asia anyway. So, but if we sanctioned the gas, all that means is that those that are buying the sanctioned gas get a discount. They still get to buy it because it's going to be very hard. I don't think we can sanction China for buying Russian gas. I just don't think that's going to happen. I think it's extremely unrealistic. So they'll keep producing gas. They have to, which, I think we'll see a realignment of interest. So the interest in having the US and Australia and Qatar, for example, those three big producers, increase their supply to the world, while Russia still needs the revenue, is favorable to lower prices, let's just say, if you're just thinking economic terms. It's favorable geopolitically because there'd be some delinking, although now we have new dependencies and links. We're strengthening the geopolitical linkages between, let's say, China and Russia. So that may have some unintended consequences. The wild cards, of course, are principally in Russia's capacity to actually operate in its environment. A lot of its gas production is in the north, in the Siberian regions, and it's technologically extremely difficult. And they've had a lot of help from the top performers in this field are the Western oil and gas companies, Exxon's, the BP's, the Shells. If those companies they've already pulled back, if they pull away, either because they're ordered to, they're sanctioned, or they're just nervous.
Yeah.
Russia runs the kind of risk that Mexico is facing now. Their production is going down, the kind of risk that Brazil faced before they let Western firms come back in. Production declines because they don't have the engineering capabilities. It's not that they're not good engineers, it's they're just not as, and it sounds, I mean, the Western oil and gas companies are just profoundly good at what they do.
Yeah.
Especially in difficult water environments like deep water and the Arctic. So that's a risk. That supply starts to slip, and it slips faster than the West makes up the difference. Then we get upward price pressure, and I don't think anybody can begin to guess the next 5 years of production in Russia at this point.
Yeah. There are a lot of Americans that believe that if we would do certain things politically on our end of the equation, that the U.S. could fairly easily make it through this little crisis moment. You commented in one of your podcasts about a fact, and you correct me if I'm not quoting you correctly on this, but you said that it's not a technology or an energy shortage issue. It's an economic, it's a policy issue. You said we're something along the line of, we are making 1.5 million fewer barrels. We're producing 1.5 million fewer barrels of oil today at $120 a barrel than we were a year ago at $60 a barrel.
Right.
Do you think America could survive most of this if we get our policy house in order?
Well, we'll survive it anyway, even with our feckless policy house right now, because
okay, good.
We're a very big economy with very high inertia.
Yeah,
and even as much damage as politicians are trying to wreak on our domestic energy industry, it's pretty resilient. But it can be destroyed, as I wrote in my book. It is possible to Sovietize an economy. The Soviets demonstrated. So, and Venezuela Sovietized their economy, but I don't think that'll happen in America. So I'm realistic that more damage could be done, but we'll survive it. We can't insulate ourselves from global pricing. So if global oil and gas prices are, a lot of pressure is put on and goes up, we will see prices rise here, which if it go up enough, we will suffer a recession too. Look, if oil prices tracked what happened the last two times we had a major interruption, we haven't had major supply interruptions except 73 and 74. And those interruptions, the 73 one took oil up 400% in overnight, 400%. So that we'd be talking $300 oil, $350 oil. And the Iranian crisis took it up 200%. So these numbers would be destructive to the economy. We would suffer a recession because of that. It would trigger a recession because it would move too much money into, the markets that need fuel, and industries would be damaged. All the trajectory. So I think that is not likely, but the crisis in Ukraine is volatile enough that you can no longer say it's impossible.
Yeah.
And if Putin were self-destructive, he said, I'm hurting. You want to hurt? You want to see hurt? I'll show you hurt. Just turn the spigots off and gas and oil going to Europe. Right. That would cause a whole lot of hurt there. And would you call that an act of war? Well, he might. Let me spin a theory. Let's just say he decided to do it in a Machiavellian way, rather than saying I'm turning off the spigot. Let's just say that the pipe got blown up, Nord Stream 1. He would blame it on Chechen terrorists or Ukrainian terrorists. Maybe his guys did it, but it actually blown up. We would see gas prices go wild because Europe would have to make up the shortfall somehow. Right. So this is what worries me about where we sit, which we have not many options except to reset. Back to the title of my piece, right? We reset our policies to send signal to the world that we don't want to be caught in this position again, and to not be caught in this position again, but because we're tied to the hip with Europe, whether we like it or not, economically. We just are. And I think that's basically a good thing. I'm just saying we are. We have to, Europe and we have to have an energy policies that economically and structurally signal to the market We're going to de-link from dependency, not no Russian oil and gas, but how about if we just get, I'll pick a number, a third of it from Russia instead of 70% if you're Germany.
Yeah.
Then you have some resilience.
That's right.
That if that were the policy of the European Union and the United States in combination, the mere act of announcing that policy in legislation, so you can't change it easily, would push down the forward price of oil and gas because markets price against future expectations.
Yeah.
And right now the expectation is either the possibility of less or the possibility of a lot less, not the possibility of a lot more. That's not the expectation yet.
Right. Yeah. Very interesting. Okay. 2 more quick questions.
I'm ready. I'll give you quick answers this time.
All right. Good. No, that's fine.
But you're going to answer questions I can't. You're going to ask. I already heard it. Renewables. You want a short answer to renewables? No, go ahead.
Yeah. No. Okay. So I listened to some of your stuff, right? Listen, you're not an anti-renewables type of guy. No. You're not a oil and gas over. So again, thinking about our industry, I'm just curious, do you ever see a place where renewables of any type will play a significant role in heat, in industry in general, but more specifically high intensity places where natural gas is used, like the heat treat industry?
No. Short answer.
Okay, now the follow-up. Why?
Well, first, the majority of processes can't be done electrically. We can use microwaves, as you know, for a lot of processes, and plasma. So there's a lot of things, a lot of work in that area, and some very promising things. But there's really no easy path to replacing the efficiency, both thermodynamic efficiency and economic efficiency of a high temperature heat flames. That's the nature of processing materials. So then the only option is the current affection for, quote, green hydrogen. So this is a profoundly misplaced aspiration. First, if we're going to use hydrogen that we could begin to afford and produce at scale, it'll be by reforming natural gas. So it's economically obvious. Stripping the carbon out of CH4 just to burn the H is expensive and energetically counterproductive. So that's the, quote, brown, stupid labels, brown hydrogen. If we want to make hydrogen by electrolyzing water, your audience understands their chemistry. The reason there's still water on the planet, there's a wonderful closed loop billion-year water cycle, is water does not want to be destroyed very easily. It's a very stable molecule. So you have to use lots of energy to get the hydrogen out. And that itself makes it inherently, not just for the present, for the foreseeable future, far more expensive than natural gas, until someone discovers a magic catalyst. And I'm not ruling that out. Is amazing. But a magic catalyst that can disassociate the hydrogen from water in some fashion that is, let's say, 10 times, not 10%, more efficient than electrolysis. That would be a big deal. But that doesn't exist. So renewables for heat, yes, sure, you make electricity with the windmills, as long as you're willing to take your electricity episodically when the market provides it. And there are some businesses that can turn on and turn off. But if you want to store electricity, then we're going to go back into chemistry world that your audience knows lots about. If you spend 10 minutes studying the physical chemistry of batteries, what you learn is, for storing energy, if I have to store energy so I can provide heat when I need it to run a process, especially continuous processes, which are very common in heat treatment, storing natural gas as a compressed gas is relatively expensive. You'd rather have a pipe bringing it in. But if you just do it in straight economic terms, how many dollars does it cost to store a therm's worth of energy in a compressed gas tank? How many dollars does it cost to store a therm's worth of energy in a battery? This is easy to figure out. It's roughly 100-fold increase in the cost per therm to store energy in a battery versus storing it. It's almost storing it, not its energetic value, just storing it. So the batteries get cheaper by a factor of 2? Sure, maybe. So it's just 50 times more expensive.
Right.
And will batteries get cheaper? I'm here to make a simple prediction I've been making for several years. No, they're getting more expensive now because they're made from materials batteries are 60 to 70% cost denominated by the commodities used to make them. And
Yes.
all those commodities are inflating because everybody wants the same commodities: lithium,
Right.
cobalt, manganese, nickel.
Yeah, and a lot of that's tied to the mining industry, which is
A very slow industry to respond.
Correct.
And
Yeah.
and a challenging industry, to say the least.
And not exactly a lot of stockpile in the North American area. I mean, most of those mines are, East
Right.
Russia, China.
Right. Africa, South America. Well, the United States is another sort of fact point. We were one of the largest mining regions on a percentage basis in the world 40 years ago. We produced 90% of the world's rare earth elements into the late 90s. We produce nearly none now. But the absolute size of the mining sector in the United States is roughly the same in tons of minerals produced now as it was 30 years ago. But the world uses about 3 times more stuff. So our share of mining has not kept up with the growth of our economy or the world's economy, because it's a hostile environment to open a mine in. We have lots of minerals. America is a very mineral-rich territory. But this administration just canceled 2 mines, that one in Minnesota to mine nickel and one in Alaska. So we're demanding more minerals.
Right.
We're going to be importing them. We are now. At least 17 critical minerals, 100% imported.
Well, maybe we ought to add to the old drill baby drill. Maybe we ought to add dig baby dig.
Oh, that you took the words right out of my report that I wrote on this a year ago.
Did you? Okay, good. Well, I read that. No. Last question. Let's come back to your book. I want to make sure our audience gets a good taste of what they would read in there. The Cloud Revolution. Why should they read it? Go ahead.
Well, to answer, so you asked, do I cover materials? The taxonomy of the book is that everything in society is based on technologies. That's what civilization is built from. Yeah. Humans are technology creating animals. That's what we do. We invent things. We build tools, but all the technologies fall into sort of 3 buckets, 3 spheres. They're about one of only 3 things. It's about information, acquiring it, moving it, storing it, processing it. Technologies for that. The technologies of machines to move, fabricate, control. We build machines. That's right. And the 3rd sphere is the sphere of materials. You can't do anything with the machines unless you have materials to make the machines and the materials machines use to make other things. That's so the universe of society is in those 3 domains. What I do in my book is map out the changes that are underway, not speculative, not theoretical, but I look at what I call the revolution that's already happened. What you want to know what the next 10 years will look like is not what was invented now or last year, but things that were invented 10 or 20 years ago that are just now reaching commercial viability. That would tell you that the tipping point towards these inflections of growth are close to us. That's much more interesting than saying, oh, fusion's around the corner. Well, no, it's not. Fusion, we don't know when fusion is going to happen.
Gotcha.
We haven't invented a commercial machine yet. That if the first commercial fusion machine had been invented, say 5 years ago, then you could say very different things about fusion the next decade. So I look at materials, machines, and information through the lens of what has just happened, and then what does that mean for employment, for entertainment, for education, and for healthcare. So I sort of map out the 4 big areas of what we want to do with machines and materials and information. I map out first the revolutions in each of those 3 spheres, where the epicenter of the revolution, that's sort of a thread through them all for the first time, is this thing we call the cloud, which is not a communications tool. It's a knowledge amplifier that's democratizing expertise, democratizing skill. I mean, everybody. If I had said 10 years ago that you'd do a lot of your data information processing, not just storage, in the cloud, every one of the companies in your audience would stare at me doe-eyed and say, no chance. They're all doing it now. You do it day to day when you do Google Map or use Airbnb, but every single industry increasingly migrates their knowledge amplification, not just their storage. Right. All the software they use, not just in the back office, but to run processes. And some of the cloud hardware might be on premise for reasons of security or latency, but it's still a cloud. The function is a cloud. I think the impact of the cloud in the three domains of communications. The cloud is impacting how we can communicate. The cloud is not a communications tool. It uses communications and amplifies it. But how it impacts the materials genome. We're moving into an era where we have something, as you know, called the materials genome, where we can use supercomputers resonant in the cloud to do what alchemists talk about for centuries, is imagine a material, imagine properties you would like, and do experiments that would take centuries. You can do them in hours in supercomputing, right?
Yeah.
Conjure up materials. But here's the key, to come back to your world. It not only all takes energy. Once the materials are conjured, which took electrical energy to conjure, it then will still take heat to make those materials, because nature doesn't want to give up entropy without you having to expend heat to fight it.
Yeah. Well, there is hope for us. There is hope for the heat treat world, and that's for sure. So
going to be a lot of heat treating going on for a long time.
There you go. Very good. Mark, thanks a lot. Really appreciate your expertise. Good to talk to you. Nice to see you again.
Good to see you again.
I'm sure we'll stay in touch, but thanks for joining us.
We hope you enjoyed listening to today's episode with Mark Mills. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to learn more about Mark, go to www.manhattaninstitute.org/expert/Mark-P-Mills, or simply search his name on the experts page. His podcast is listed on his page, or you can go to Amazon.com to purchase any of the 4 books you heard mentioned today, including the latest, The Cloud Revolution: How the Convergence of New Technologies Will Unleash the Next Economic Boom, and A Roaring 2020s. Also, as always, if you're wanting to hear more about a specific topic as it relates to Heat Treat, do let me know. Or if you'd like to sponsor a future episode, email me at bethany@heattreattoday.com and I'll be in touch. One last note, we're 1 month away from officially beginning the 40 Under 40 class of 2022 nominations. This is an amazing opportunity to highlight the young movers and shakers in the North American heat treat industry, so don't miss it. Nominate yourself or a client so that we can celebrate 40 heat treat professionals under 40 years old this September. Heat Treat Radio would like to thank the Heat Treat Buyer's Guide for sponsoring this episode. Find your heat treat solutions at www.heattreatbuyersguide.com. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.